Now it turns out that there is a much faster way to tell if a matrix is singular or non-singular, and in this video you will learn it. It's called the determinant, and it is a quick formula that returns a 0 if the matrix is singular, and a number different from 0 if the matrix is non-singular. Take a look back at the matrix in the previous example, and let's focus on the singular matrix on the right. In this matrix, you can multiply the first row by 2 to obtain the second row, and therefore the rows are linearly dependent. In contrast, for the non-singular matrix on the left, there's no number that you can multiply the first row by to get the second row, because the rows are linearly independent. Let us look at this more carefully. If a matrix has entries A, B, C, and D, then the matrix is singular if there exists a number k for which the first row times k is equal to the second row. That means AK equals C and BK equals D for the same value of k. This is equivalent to C over A equals D over B equals k. And that's the same thing, forgetting about k, that AD is equal to BC. Or, equivalently, AD minus BC equals 0. This value of AD minus BC is very important. We're going to call it the determinant of the matrix. So the determinant of the matrix is AD minus BC. And by construction, this determinant is 0 if the matrix is singular and non-zero if it's non-singular. Now, a way I like to look at the determinant is like this. AD is the product of the numbers in the main diagonal, and BC is the product of the numbers in the anti-diagonal. So let's calculate the determinants of these two matrices in the ongoing example and see what you get. The first matrix has determinant 1 times 2 minus 1 times 1, which is 1. And the second one, 1 times 2 minus 2 times 1, which is 0. So notice that the first matrix, which is non-singular, has a determinant of 1, which is non-zero, and the second matrix, which is singular, has a determinant of 0. This is no coincidence, this is always going to be the case. Non-singular matrices have non-zero determinants. They don't need to be 1, but they're non-zero. And singular matrices have 0 determinant. To summarize, the determinant of a matrix with entries A, B, C, and D is AD minus BC, and it is 0 precisely when the matrix is singular and non-zero when the matrix is non-singular. So now you're ready for a quiz. In problem 1, you have two matrices and you're asked to find their determinants. And in problem 2, determine if the matrices are singular or non-singular based on the results of problem 1. And the answers are, for the first matrix, the product of the terms in the main diagonal is 5 times 3, which is 15. The product of the terms in the main anti-diagonal is 1 times minus 1, which is minus 1. And the difference is 15 minus minus 1, which is 15 plus 1, which is 16. Since the determinant is different from 0, then the matrix is non-singular. For the second matrix, the determinant is 2 times 3 minus 1 times minus 6. So the 3 minuses means that's 1 minus. So the determinant is 6 minus 6, which is precisely 0. Since the determinant is 0, then the matrix is singular.